Hello everyone, my name is Sachin and in this video, I'll discuss the mathematics paper of part test 17. So question 51, there are two particular days where an employee is absent. And by the way, I hope this clarification was made in your exam. This is not at least one meeting, it is at least one project. So for the employee to miss at least one project, it means that at least one project should be allocated during those 2 days where the employee is absent, right? So here the number of trials is 2, n equals 2. On these 2 days, the employee is definitely uh, absent. On any of these days, the probability that a project is allocated is 1 by 7, which means the probability that it is not allocated is 6 by 7, right? So the probability that on these 2 days, our projects are allocated will be NCR into Q power N minus R into P power R, which is 2CR into 6 by 7 whole power 2 minus R into 1 by 7 whole power R. Now, for the employee to miss at least one project must be allocated on those 2 days, which means you have to find probability of X greater than or equal to 1, which is P of X equals 1 plus P of X equals 2. Question 52. Two cards are drawn from a pack of 52 cards. So here the number of elements in the sample space is 52C2 because out of 52 cards, the number of ways you can pick any two is 52C2. Now the probability that both cards are either black or queens. Now remember in any standard deck, there are 13 black cards and 4 queens, right? But out of these, there is one card which is both black and a queen. So the number of cards that are available is 17 minus 1. That's 16 because one card is being counted twice, both as a black card and as a queen, right? So what is the number of favorable outcomes here? Out of these 16 cards, you have to pick any two, right? So the required probability will be n of E by n of S, that is 16C2 divided by 52C2. Question 53. Number of ways in which 4 different red roses, 4 different blue roses, and 5 alike green roses can form a garland so that flowers of the same color should be together. So there's a circular permutation and flowers of the same color should be together, which means you have to consider all flowers of the same color as one group, right? So if you do that, you get 3 groups. One group has only red roses, one group has only blue roses, and one group has only green roses. Now, these 3 groups can be rearranged in a circular permutation in 2 factorial ways. Remember, if there are n objects or n groups, they can be arranged in a circular permutation in n minus 1 factorial ways. Now, among these, you can also rearrange the red roses among themselves because all the red roses are different. This can be done in 7 factorial ways. Then the blue roses within that group can be rearranged in 4 factorial ways. Now, because all the green roses are alike, there is no need of any rearrangement. So that is only one way, right? And now the important thing here is clockwise and anti-clockwise circular permutations need not be counted as separate, right? They must be, they need not be counted as, when say do not distinguish clockwise and anti-clockwise circular permutations, it means both of them are the same, right? If you say do not distinguish, it means that don't treat them as different things, treat them as the same things, which means the number of circular permutations is effectively halved. So this becomes 7 factorial times 4 factorial. Question 54. The number of triangles that can be found with the vertices of a polygon of 8 sides if the triangle cannot have any side common with the polygon, right? So here, there is no side common with the polygon. So what we can do here is we can count the total number of ways in which three vertices can be selected, right? So if there are n vertices, the number of ways of selecting three vertices is nc3. From this, we have to subtract all those cases in which there is at least one side common with the polygon, right? Now, how do we make sure that there is at least one side common with the polygon? To understand that, let us make an eight-sided polygon here, right? So first, we will count the number of ways in which exactly one side is common, right? So let us say that I have picked two particular vertices, two consecutive vertices for the polygon, right? This can be done in how many ways? This can be done in n ways because I can select vertex 1 and 2 or 2 and 3 or 3 and 4 and so on up to 8 and 1. So this can be done in n ways. Now, each time you pick two consecutive vertices, the number of ways in which you can select the third vertex becomes n minus 4 because these two vertices are already taken and you cannot take any vertex that is adjacent to them. So out of n vertices, two are already selected and two more are not to be taken. So you can pick the third vertex from the other n minus 4 uh, vertices, right? So this is n into n minus 4. This is the number of triangles in which exactly one side is common. Now, to make sure that exactly two sides are common, you have to pick three consecutive vertices, right? And the number of ways of doing that is also n because you can either pick 1, 2, and 3, or 2, 3, and 4, or 3, 4, and 5, and so on up to 8, 1, and 2, right? So this will be n, right? So uh, this is the solution for a general polygon with n sides. You can easily apply this to a polygon of 8 sides. Question 55. P of E is 0.15, P of F is 0.09, P of E intersection F. Okay, so here you have probability of F intersection E complement, which can be written as P of F union E minus P of E, right? Because in the Venn diagram, if I have two sets E and F, and I want to find F intersection E complement, that is F minus E, right? Then from the union of the two sets, I should remove the second set. So here it is P of F union E minus P of E, right? So what will that be? P of F union E is given as 0.19 minus P of E is 0.15. So the answer should be 0.04. Question 56, the standard deviation of the first n multiples of 3. So what are the first n multiples of 3? I can write this as a set containing 3, 6, 9, and so on up to 3n, right? So these n terms form an E. Now, when I say first n multiples of 3, I could have started with 3 or I could have started with 0. Or maybe I could have started with minus 3. But that doesn't matter here because in an AP, the variance depends only on the common difference. It does not depend on the first term of the AP. Right? So in an AP, how do you find the variance? The variance is n square minus 1 by 12 times the common difference, right? So in this case, it will be n square minus 1 by 12 times 3, right? So this is the variance. To find the standard deviation, you need to take the square root of, okay, so sorry, so this should be d square, n square minus 1 by 12 times d square. So here, this should be n square minus 1 by 12 times 3 square. And to find the standard deviation, you need the square root of the variance. So the standard deviation will be 3 times under root n square minus 1 divided by 12. Right? So that was question 56. Question 57, NC3 plus NC4 is greater than n plus 1C3. So now I can write this as NC4 is greater than, okay. So I have NC3 plus NC4 greater than n plus 1C3, right? Now what do you notice here? The left-hand side is of the form NCR plus NCR minus 1, right? And what is NCR plus NCR minus 1? It is n plus 1 CR, right? Which means the left-hand side, that is NC4 plus NC3, can be written as n plus 1 C4 greater than n plus 1 C3, right? Now, there is one result that you can use here, which is NCR divided by NCR minus 1 is n minus R plus 1 whole divided by R. There is that, or you can also expand n plus 1 C4 and n plus 1 C3. That will also give you the answer. Anyways, n plus 1 C4 divided by n plus 1 C3 should be greater than 1. This means n plus 1 minus 4 plus 1 divided by 4 should be greater than 1. Right? So I've made use of this result here. Even if you expand the binomial coefficients and simplify, you will get the same inequality. So from here, n minus 2 by 4 is greater than 1. So n should be greater than 6. Question 58. For two data sets, each of size 5, the variances are given to be 4 and 5, and the corresponding means are given to be 2 and 4 respectively. Right? So I hope this is 2. So let us take data set 1, where the mean of 5 observations is 2. Right? So what is the sum of those 5 observations? It will be 10. Right? For the second data set, the sum of the 5 observations will be 20. Right? Because mean is sum of observations by number of observations. There are 5 observations and the mean is 4. Then the sum of the observations must be 20. To find the variance of the combined data set, we need sum of the squares of all the observations. Right? Now for the first data set, the variance is 4, and there is a very useful uh, formula for finding the variance, which is the mean of the squares minus the square of the mean. Right? This should give you the variance for the first data set. This is given to be 4. We already know that the mean is 2. So I can say sigma xi square is 5 times 4 plus 4. So this is 80. Right? Similarly, for the second data set, sigma yi square by 5 minus mu square. I'll write this as mu1 and mu2. This is to be 5. So sigma yi square, sum of squares of the observations in the second data set will be 5 times 5 plus 4 square, that is 16. So this will be 5 times 21, that is 105. Which means for the combined data set, the sum of all the observations will be sum of all the observations from the first set plus sum of all the observations from the second set. This is 30. And for the combined data set, the sum of the squares of all the observations will be 185. Now you can again use the formula for the variance to calculate the variance of the combined data set. So the variance will be mean of squares, and here there will be 10 observations minus square of mean. This will be sigma zi by 10 whole square. So this will be 185 by 10 minus 3 square, right? So that is 18.5 minus 9. So I think the answer is 18.5 minus 9. Variance, to get the variance is correct here. Mu1 square is 4. Mu2 square is 16. 18.5 minus. Okay, we'll get back to this question here because I'm getting the answer to be 9.5, but it doesn't seem to be one of the options. I'll get back to this question in a moment. Question 59. Let A, B, C be three events in a probability space. Suppose that P of A, P of B. Okay. Now the smallest possible value of P of A complement plus P of B complement. Sorry, P of A complement intersection B complement intersection C complement. Now this can be written as P of A union B union C whole complement, right? Because A complement intersection B complement intersection C complement is A union B union C whole complement, which can be written as 1 minus P of A union B union C, right? Now this is 1 minus. How do we expand P of A union B union C? We have P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C, right? So let us say this is the required value. We will call it lambda. On the right hand side, we have 1 minus of P of A plus P of B plus P of C is 1 minus P of A intersection B plus P of B intersection C plus P of C intersection A is 0.25 plus 0.06. So that's 0.31. Plus we have an unknown quantity here, which is P of A intersection B intersection C, right? So if you simplify this, you will get P of A intersection B intersection C is uh, lambda minus 0.3, right? Now remember that you're dealing with P of A intersection B intersection C, which must always lie between 0 and 1, right? P of A intersection B intersection C must lie between 0 and 1 because it is a probability. And in fact, to be even more accurate, P of A intersection B intersection C should be less than P of A union B union C, right? So that is also important. But here, in this case, we only need the minimum value of lambda, right? Now, lambda minus 0.31 can be strictly greater than 0, which means lambda is greater than 0.31. Smallest possible value is 0.31. And if we want to find out the largest value, then we have to use the other inequality. But of course, that involves P of A union B union C, right? Question 60, A1, A2, A3 are positive terms of a GP, and A4, 1, 2, and A10 are the consecutive terms of the. So let us take a general term for this GP. Let us say A4 is AR cube, and A10 is AR power 9, where A is the first term and R is the common ratio, right? Now here these three are consecutive terms of another GP, which means I can write 1 by A4 equals 2 by 1 equals A10 by 2. Because in a GP, the ratio of T2 by T1, T3 by T2, T4 by T3, and so on should be the same, right? So from here, I will get A4 is 1 by 2 and A10 is 4, right? So AR power 9 is 4 and AR cube is 1 by 2. So from these two equations, you can calculate the values of both A and R, right? So you'll get the values of both A and R, and you're being asked for product of AI, right? So what is product of AI here? This means this expression uh, pi of AI. This means you have to start with A2, A3, and multiply these all the way up to A12, right? So what will this be? A2 will be AR, A3 will be AR square, and so on up to A12 will be AR power 11, right? So this expression will be nothing but A power, how many terms are there here? From 2 to 12, there are 11 terms. So a power 11 into r power 1 plus 2 plus 3 and so on up to 11. So this will be a power 11 times r power 66. Right? So this is a r power 6 whole power 11. So once you get the values of a and r, you can substitute them in this and you'll get a r power 6 whole power 11, the value of a r power 6 whole power 11. Question 61, a swimming team has 8 members, only 2 of them are boys. Right. So there are 2 boys and 6 girls. Coach wants to take a delegation from the team to a special swimming camp. The delegation must have either 5 or 6 members. This means that there are 2 cases. Either there are 5 members in total, or there are 6 members in total. And this delegation must include at least 1 boy, which means if you're dealing with 5 members, it can either be 1 boy and 4 girls, or it can be 2 boys and 3 girls, right? Because there are no more than 2 boys, you do not have a case of 3 plus 2. Similarly, for a 6-member delegation, you can either have 1 boy plus 5 girls, or 2 boys plus 4 girls, right? So now you simply have to find the number of ways of forming each of these combinations and add, right? So the correct answer will be for 1 boy and 4 girls. To select 1 boy and 4 girls, you can do it in 2C1 into 6C4 ways, plus for 2 boys and 3 girls, 2C2 times 6C3. Then you have 1 boy and 5 girls, which is 2C1 into 6C5. And then 2 boys and 4 girls can be selected in 2C2 times 6C4 ways, right? So this will give you the answer to the question, what is the number of ways of selecting a delegation? Question 62 is one of the easiest in this paper. You need the sum of the coefficients in the expansion. If you see, this is a polynomial of the form f of x, right? And whenever you see a polynomial of the form f of x, the easiest way to find the sum of all the coefficients is to substitute x equals 1, right? So this is by far the easiest question in this paper. To find the sum of the coefficients, you just need to substitute x equals 1. Question 63. The height of the students is given, right? And the median of the distribution is being asked. Now, how do you find the median of the distribution? First, you have to sort the data given so that all the observations are in ascending order, right? So if I sort the students in ascending order, first I will get all the students whose height is 150. So that's 8 students. Then all the students whose height is 152, 4 students. Then there is the students whose height is 154 centimeters. So there are 3 such students. Then there are 155 there are 7 students with height 155 centimeters. Did I miss anything? Yes, 156 centimeters. There will be 3 students. Then 160 centimeters, 12 students, and 161 centimeters. There are 4 students, right? Now, remember, when you want to find the median, you arrange all the observations in ascending order and you find the middle term, right? Now, what is the total number of observations here? What is the total number of students? So that's 12, 15, 22, 25, 37, 41, right? So let me just check. 12, 15, 22, 25, 25 is 41 students, right? So if there are 41 students, the middle term or the observation that occurs exactly in the middle is the 21st student, right? Whatever the height of the 21st student is in this ascending order, that will be the median of the distribution, right? So let's look at where the 21st observation occurs from the beginning, right? So if I take the cumulative frequency, right? If I add the first 2 terms, I get 12 students. So up to this point, there are 12 students. So the 21st student is not in this group. Then if I add 3, I get 15 students. The 21st student is not in this group. Now, if I add 7, I get 22 students, right? So if I start ranking the students from 1 to 41, the 21st student will be in this group. This class is called the median class, right? So what is the median of this distribution? It is 155. So question 64, for the observations given, if the mean and variance of the observations is lambda and mu respective. Now, here, first I will find the mean of the observations xi minus 5, right? So for x1 minus 5, comma x2 minus 5, comma x3 minus 5, and so on, what is the mean? The mean is number of sum of observations, that is 10, divided by number of observations, that is also 10, so mean is 1. To find the variance, I need mean of squares, which is 40 by 10, minus square of mean, which is 1 square, this is 3, right? Now remember, you are being asked for the variance, mean and variance of a new data set, that is x1 minus 3, x2 minus 3, x3 minus 3, and so on, right? Now, how is the new data set related to the old data set? From the old data set, you are adding a constant to the new data set. Now remember, whenever you add a constant, the mean will change, right? If each observation increases by 2, then the new mean is also increased by 2. But remember, adding a constant to the observations does not change the variance. So the new variance will be the same. So it will still be 3. All right, so let's move to question number 65. Let f of x be a function such that f of x plus y equals f of x into f of y. So here we are dealing with an exponential function because only exponential functions have this characteristic, right? So let f of x be an exponential function of the form lambda power x. And we also have information about f of 1, right? F of 1 equals 3, which means lambda is 3, right? Now you want sigma f of k, which is f of x is lambda power x, which means f of k is 3 power k. And what does the summation mean? It means you have 3 power 1 plus 3 square plus 3 cube and so on up to 3 power n is 3279, right? So the left hand side is a GP, is a sum in terms of a GP. So it will be the first term times 1 minus 3 power common ratio to the power number of terms by 1 minus 3. A into 1 minus r power n by 1 minus r. This is 3279. From this you can calculate the value of n, right? Question 66. You have A1, A2, A3 are n positive conjugated points of an arithmetic progression. And you have a summation to deal with here, right? So you have limit n tends to infinity, which means first we need to simplify this term, right? This term in the bracket and see if it depends on n and how it varies as n varies, right? So the first term in this sequence in the brackets is 1 upon root a1 plus root a2. If I rationalize this term, I will get root a2 minus root a1 by a2 minus a1, which can be written as root a2 minus root a1 whole divided by 2, right? So now that's the first term, which means I can write the required summation, that is this part, right? The summation inside this bracket can be written as root a2 minus root a1 divided by d plus root a3 minus root a2 divided by b plus root a4 minus root a3 divided by b and so on till I reach root an minus root an minus 1 divided by b. And as you can see, like most telescopic summations, if you convert this summation in this form and add, most of the terms will get cancelled out. A2, root a2 will get cancelled out, root a3 will get cancelled out, and so on till only 2 terms remain, right? So this summation will be root an minus root a1 divided by. which means your required summation here, the required limit here is limit as n tends to infinity square root d by square root n times root over n can be written as root over a1 plus n minus 1 times d, right? Minus root over a1 whole divided by. And remember, when you're trying to solve limits as n tends to infinity, 1 by n tends to 0. So first I need to uh, take root n common, right? So if I rearrange the terms here, I'll get limit as n tends to infinity. After simplifying these two terms, I will get 1 by d in the denominator. I also have 1 by root n. And if I want to take n common from these two terms in the numerator, I will get root n times root over a1 by n plus 1 minus 1 by n times d minus root over a1 by n, right? So I can cancel this root n and this root n. Now as n tends to infinity, 1 by n tends to 0, which means this term will tend to 0, this term will tend to 0, and this term will also tend to 0, which means what is the value of the limit after evaluating it? So in the numerator, you are left with square root d, and the denominator also have square root d, which means the answer is 1, right? Question 67, we have f of x is of the form ax plus b by cx plus d. F of x is of the form ax plus b by cx plus d, and quite a common occurrence in recent mains papers. We can observe that here a plus d is 0. And if that is the case, you can say that f of x will be x, right? And similarly, f of 4 by x will be 4 by x, right? So you'll see that the coefficients given in the original function have nothing to do with this problem because f of x is nothing but x and f of 4 by x is 4 by x. So to find the least value of x plus 4 by x, you need to apply AMGM inequality. So I can say x plus 4 by x whole divided by 2 is greater than or equal to x times 4 by x whole power 1 by 2, right? And how do I know I can use AMGM inequality here? Because it is specified that x is positive, which means both the terms involved are positive real numbers. Question 68, the mean and standard deviation of 10 observations are 20 and 8 respectively. So the standard deviation is 8, which means the variance is 64. Later on, it is observed that one observation was recorded as 50 instead of 40. So you need to replace that wrong observation, right? So the mean is 20, which means the sum of all the observations is 200, right? Because sum of observations by number of observations is 20, there are 10 observations. So summation xi is 200. And variance is 64, which means mean of squares minus square of mean is 64. From here, you will get summation xi square equals 10 times 464, right? So this is 4640. But remember, when calculating this data, one observation was recorded wrong. So from the sum, for the correct sum, right, you have to remove the wrong observation and add the correct observation. So the correct sum of observations is 190. Similarly, the correct sum of squares of the observations. From the calculated sum, you have to remove the square of the wrong term and then add the square of the wrong term. From here, you will get the correct sum of observations. And then you can proceed with finding the correct variance, right? Question 69. Ajay not appear in JEE with probability P equals 2 by 7. Well, both Ajay and Vijay will appear in the exam with probability 1 by 5. And the probability that Ajay will appear and Vijay will not. So here I can define these as two events, right? Let us call them A and B, right? What is given here? P of A complement is 2 by 7. Probability that, let's say I define A as the event of Ajay appearing in the exam and B as Vijay appearing in the exam. Then the probability of A complement is 2 by 7 and probability of A intersection B is 1 by 5, right? Now the probability that Ajay will appear in the exam and Vijay will not appear. That is, I have to find the probability that Ajay appears in the exam and Vijay does not appear in the exam, right? So probability of A intersection B complement. This can be written as probability of A minus V, right? And remember, earlier we discussed how to write probability of A intersection B complement, or I think we'd use different symbols for the intervals there. Where was that question? F intersection E complement, right? Now there is another way of writing probability of F intersection E complement. I can also write this as probability of F minus probability of F intersection E, right? From the set F, I can do F intersection. And that result is particularly useful in this problem, right? Because now I can write this as P of A minus P of A intersection. And P of A is known because P of A complement is 2 by 7. So P of A is 5 by 7 and minus P of A intersection is 1 by 5. Question 70. The number of ways 5 alphabets can be chosen from the alphabets of the word mathematics, where the chosen alphabets are not necessarily distinct, right? So it means that you are under no compulsion to select distinct letters. And that becomes important because in this word, there are groups of similar letters, right? For example, there are two N's, two A's, two T's. Is there any other letter that is repeating? No, there is an one H, one E, one I, and one C, and also one S, right? Now you have to choose 5 alphabets from this. And that becomes important because there is no restriction on whether you choose distinct alphabets, right? Which means you have to break this down into cases. What are the different cases? One is all are distinct. All 5 letters are distinct. So for that, you need to select 5 letters from among 1, 2, 3, 4, 5, 6, 7, 8. 8C5. Right? All distinct are 8C5. Now let us say that the second case is there is at least one pair of uh, identical letters. Right? So let us say there is one pair of identical letters. So that means you can choose one pair of letters from the 3 available, right? And then from the remaining 7 letters, you can choose any 3, right? So here this is important because let us say out of these 3 pairs, I've chosen one pair, right? Let us say I've chosen 2 M's. But then the other 3 letters can also be A or T without repetition. That is why I have to count that as 7C3. Now let us say there are exactly 2 pairs of identical letters. So again, the same thing, 3C2, I will choose 2 pairs of identical letters. And then from the remaining 6 letters, right, I will choose one letter, right? I cannot have 3 pairs because that would make it a selection of 6 alphabets, right? So your final answer should be the sum of all these cases. Your final answer should be 8C5 plus 3C1 times 7C3 plus 3C2 times 6C1. Question 71. R is the remainder when 6 power 83 plus 8 power 83 is divided by 49. Now, generally, when we do this, we solve each part separately, but I can observe one thing very significant here. That is, the first term is 7 minus 1 whole power 63. The second term is 7 plus 1 whole power, sorry, not 63. First term is 7 minus 1 whole power 83. The second term is 7 plus 1 whole power 83, right? So this is a binomial expansion of the form a plus b whole power n plus a minus b whole power n. So this can be written as 2 times the sum of so this can be written as 2 times the sum of all the odd numbered terms, right? So this will be 2 times uh, the first term, which is 83C0 into 7 power 83, plus the third term, which is 83 to C2 times 7 power 81, plus the fifth term, which is 83C4 times 7 power 79, and so on, right? So this expansion will have how many terms? 84 terms, which means the 84th term must also be written. This is 83C83 times 1, right? Now it's quite interesting to even write the term just before that, right? But the term just before that will be 83C18, oh, sorry, 83C, 83C80 into 7 cube plus 83C82 times 7. Now this must be divisible, this must be divided by 40. But what do you observe? You observe that out of all these terms, everything except the last term is divisible by 49, because 7 power 83 is divisible by 7 square, 7 power 81 is divisible by 7 square. So all you need to do is calculate R is the remainder when 2 into 83C82 into 7 is divided by 49, right? So this will be 2 into 83 into 7. So just find out this product and see what happens when it is divided by 49. Balls are arranged in rows to form an equilateral triangle. The first row consists of 1 ball, second row of 2 balls, third row of 3 balls, and so on. If 669 more balls are added, then all the balls can be arranged in the shape of a square, and each of the sides then contains 8 balls less than each side of the square. Then the initial number of balls must be. Okay, so to process this question takes quite a bit here, but so let's say there are n balls here. They are arranged in rows to form an equilateral triangle. So let's say first I arrange 1 ball in the first row, 2 balls in the second row, right? So if I have an equilateral triangle with 2 rows, then each side contains 2 balls. If I make an equilateral triangle with 3 rows, then each side will contain 3 balls, right? So let us say that and if I add 4 rows, then there will be 4 balls in each side, right? Because here there are 4 rows forming an equilateral triangle. The number of balls in each side is 4, right? So to solve this question, let us say the number of the side of the triangle is n. Let us say the number of balls in each side is n, which means the number of rows will also be n, right? There will be n rows in this triangle. So how many balls will be fit in n rows? That will be 1 plus 2 plus 3 and so on up to n. Because the first row has 1 ball, second row has 2 balls and so on. The nth row will have n balls. So this is n times n plus 1 by 2, right? Now let's try to see what happens when I want to form a square, right? So if I make a 2 by 2 square, then each side will have two balls. If I make a 3 by 3 square, then each side will have three balls. If I make a 4 by 4 square, then each side will have four balls, right? Now, the side of the square is eight balls less than the side of the triangle. So let us say here, if the side of the triangle is n, then the side of the square is n minus 8, right? But then, what is the total number of balls required to make the square? It is n minus 8 whole square, right? But it says that the number of balls required to make the square is 669 more than the number of balls required to make the triangle, right? So you have n minus 8 whole square minus n times n plus 1 by 2 is 669. So again, you have a quadratic equation that you must solve, right? So if you get two answers, two possible answers, please be careful about which answer you pick, because here it is necessary that the number of balls used is at least 9, right? Because n minus 8 must be a positive integer. Question 73, in a class of 60 students, 40 opted for NCC, 30 opted for NSS, 20 opted for both NCC and NSS. So let's define this as events A and B, right? A and B. The probability that a student selected has opted for neither NSS nor NCC. So that is probability of A complement intersection B complement, neither NCC nor NSS. So this can be written as 1 minus probability of A union B, because A complement intersection B complement is nothing but A union B whole complement, right? And to find P of A union B, we need to find P of A plus P of B minus P of A intersection. And all that information is already given in the question. N of A is 40, so P of A is 40 by 60. N of B is 30, so P of B is 30 by 60, right? Question 74, X and Y are distinct integers such that X lies between 1 to 25 and Y lies between 1 to 25. Then the number of ways of choosing X and Y such that X plus Y is divisible by 5. So I hope you've revised the concept of divisibility here. For X plus Y to be divisible by 5, the sum of the remainders must be divisible by 5, right? And this is important because whenever you divide any number by 5, the possible remainders are 0, 1, 2, 3, 4, right? So here, when I choose X and Y, then X must leave remainder 0 and Y can leave remainder 5, or X can leave remainder 1 and Y 4, X2 and Y 3, X3, Y 2, X4 and Y 1, right? And okay, sorry, here this should be 0, 0 because you can't have remainder 5. So either both X and Y must be divisible by 5, right? Or X must leave remainder 1, Y must leave remainder 4, or X must leave remainder 2, Y must leave remainder 3, and so on. Now let's group our numbers here. When I have 1 to 25, what are the numbers that leave remainder 0, 1, 2, 3, 4? So the numbers that leave remainder 0 are divisible by 5. So these are 5, 10, 15, 20, 25, right? The numbers that leave remainder 1 are 6, 11, 16, 21, uh, 6, 11. Oh, sorry, I forgot the most important one. 1 is also one of those numbers. 1, 6, 11, 16, 21, right? So the numbers that leave remainder 2 are 2, 7, 12, 17, 22. So as you can see, there are 5 numbers in each group, right? So to select X and Y from the first group, the number of ways is 5 into 4. It is not 5C2, is it? It is not 5C2 because X and Y are different. X and Y are distinct integers. So X can be chosen in 5 ways, Y can be chosen in 4 ways, right? But when it comes to the second group, X must leave remainder 1, Y must leave remainder 4. You can do this in 5 into 5 ways. Same goes here, same thing here, and same thing here, right? So the number of ways of choosing X and Y, if X and Y are different, distinct, right? This will be 4 times 5 square plus 5 into 4. Question 75, the number of integral terms in the expansion. So this is again a straightforward problem. First, you have to write the general term in the expansion. PR plus 1 is 680 CR times 3 power 1 by 2 whole power 680 minus R into 5 power 1 by 4 times R, right? So if I simplify this, I get 680 CR times 3 power 680 minus R by 2 into 5 power R by 4, right? And what values can R take here in the general expansion? R can lie between 0, 1, 2, 3, and so on up to 680. But for this term to be an integer, 680 minus R by 2 must be an integer, and R by 4 must also be an integer. This means that R must be a multiple of 4. Right? So what are the multiples of 4 within the set that is given to us? So R can be either 0, 4, 8, and so on up to 680. So you just need to count how many such values of R are there. And as you can see, all of them form an AP. So it will be quite easy to find the number of terms in this AP, where the first term is 0, common difference is 4, and the nth term is 680, because 680 is also divisible by 4. So let's get back to that question there, because I'm quite sure, not quite sure whether I made a calculation mistake here. Two data sets, each of size 5, variances are 4 and 5, means are 2 and 4 respectively. Unless I wrote this question wrong, if I've taken this mean as 2, right? So let me check what the exact question is. 8, 2 and 4, right? Okay, so for the first data set, sum of the observations is 5 times 2. For the second data set, sum of the observations is 5 times 4, right? For the variance, mean of squares minus square of mean is 4. So mean is 2. So 2 square. Oh, I'm so sorry. So I made a calculation mistake here, right? So there was a calculation mistake here. Instead of 16, this should be 8. So this sum should be 40. So there's something. So I made a calculation mistake here, which you must always try to avoid. So yeah, so what happened essentially here is this should have been 8 instead of 16, right? So the correct answer will be 14.5 minus 9, which is 5.5, right? So my bad. Anyway, so that concludes our discussion of this paper. Thank you very much.